Hello everyone. So I'd like to introduce my bonus project. So firstly, I'd like to introduce my source code and which part of my source code was implemented by myself, because this source code was based on a simulation framework. So there's a lot of codes of that framework. So I want to clarify that which part was implemented by myself. So first, we can look at this source code here. So as we can see, there's a folder called labs. So in this lab, there's three folders called client server, Paxos, and ping pong. So ping pong, and we can see each folder has two subfolders, and the source of this folder was mostly implemented by myself, but the tests folder was not implemented by myself. So the main part of this protocol was in this folder, Paxos, and the source code here. And this folder is, I implement some of this code. It's just a test to see if the client and the server can communicate. This communication works well or not. And this folder, I implement something which is a basis for Paxos. We can see here. Here's the almost once and a KV store and client server. So the main part is the first one is KV store. So you can see in the code here, no, it's this one, KV store. So if you can see this annotation, then the following code was implemented by myself. So this KV store, this file is an application. Based on this application, this is a framework thing, and this KV store was implemented by myself. This KV store is an application that has three commands. One is get, and the other is put, and another is append. You can imagine it as a map. So this KV store will be stored in every server. If the server get commands from a client, for example, a command called get, so this KV store application will execute get, right? And then there's another thing called it's most once application. So this application is actually it has a KV store in it. So the function of this application is that you can, for example, if the server gets three same commands from clients, and these clients have same sequential number, so the server don't need to execute three times, but just need to execute once. So this is what this almost once application do. So KV store was in this almost once application, and this application is in every server. For example, for each server, this is a file I define every server. So in this server, we can see here's a application. This application, okay. So for the Paxos part, we mainly have Paxos server and the Paxos client, because all my three rows are in one Paxos server. So I just define this file, and the client, the target for client is very easy. That it will send commands, and with the sequential number. For example, the first command with the sequential number is one, and if it didn't get the reply from the server, it will send again with the same sequential number until it get the reply, and the next it will send another command. This is what this Paxos client do. So you can see here, these are not my code. This is from the framework. The framework defines the whole framework here. So my job is just to implement these functions. So my code here, this is my code here, and my code here. This function was and this handle functions is to handle messages. If the client get a message called the type is Paxos reply, then this function will be called. And it has a timer. If the timer expires, it will send a command, the same command we just sent. So this is what the client do. And we can see here there's a lot of, and there's four official functions from the framework, but the framework didn't define anything here. So the methods, the name of methods was provided by the framework, but the methods was implemented by myself. So, and here's a lot of functions, handle functions. All these handle functions was implemented by myself, and these utils also implemented by myself. And for other things like messages, these messages was also implemented by myself too. And Paxos reply, this is another message. And timers. So next, I'd like to introduce what did I implemented in this project. We can see the report here. I have written them. First, I implement this KV store application and almost once application, and second, I implement this whole protocol like this. And also my Paxos can deal with hosts. This is a kind of optimization. And also I have stable leaders. It's another optimization to make the whole process work more efficiently. And it has garbage collection, and it has state reduction. It's also an optimization. So, and I have more optimization to stick with one stable leader. So this is in the high level what I implemented. So now I'd like to give a demo that we can compile it and run it. First, we need to be as in the root file, like this directory, and at this directory we need to run make. So if you have this message, it means that we have make it before, so we need to clean. So now we run make. So here we can see we have built successful, and then we can run the tests. So by the way, the source of tests are in this folder. And these tests are provided by the framework. It's not written by myself, but these tests provide very good simulations. So they have a lot of tests. First, it's a very basic one to check the system is running or not. Let's see this test. It sets 3 servers and see if one client can run good or not. And we have a lot of tests. We have in a total of 13. So here, if we want to run some tests, we can run run tests.py -t, and you can input your test number here. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, that's run test .py. It's not run test. So here we can see we passed these tests. And this is garbage collection. It will detect if how many memory we are using to see if we collect garbage or not. And these 2 tests are actually unreliable network. So, and there's nothing that if you want to see the process when the protocol is running, here's the flag. Here's a lot of flag. If you want to see which message, you can turn this true or not. The whole button here is that we turn off print. If we can turn this false, and now we can see we don't need to make again. We just run it. We can see, for example, if we run 2, we can see the log file. Okay, so this is a log file. I can explain this. So we can see this is server, every server's message, and if this is true, it means that it is the active server, and if it's false, it means that it's not an active server. So for example, we can see this server. How does this server work? So there's a lot of information. Oh, it's too much. We can see part of it. So this is a stable server. You can see other servers was always false. If this server is not fail or crash, so this server will always be true. This is kind of optimization to speed up the whole process of Paxos. So this server, it will send P2A to acceptor to get the consent, and for each command, it will generate a commander to send to P2A. And we can see here, the beta number is its beta number, and it's a non-operator. This is how we deal with holes. If there's holes in the log, we need to put a non command in this to make sure the progress is still live. Otherwise, it will fail. This is what I just told in here. Deal with holes. This is how I deal with holes. In my design, I will put a non-operational command into that hole. Then we perform that command. We just doing nothing. Thus, the program will be alive. And we can see other commands. Yeah, this is category from acceptors. And if you want to see the detailed thing, you can see here. So, and there's another thing that I also write a document. If you see the code, this is too messy. If you want to see what I implemented, you can see here. Here's the rows in my Paxos. So there's 4 rows in the system: leader, acceptor, replica, and the client. So this is how each row is what does this row doing. In a high level, we can go over this a simple example. For example, first the client will send a request, and it will broadcast 2 requests to all the replicas. And if the replicas got this request, it will send a propose to the leader. And there's only one leader in this example, but in my example, there's actually a lot of leaders. Actually, in my implementation, each server will play the role of all the 3 rows. So I mean, for each server, it is a replica, and it is a leader, and it is an acceptor too. So for this leader, if first when it start up, it will need to initialize itself. It will send a scout. This is a function, and we will broadcast 3P1A to the acceptors. And if the acceptor accepts its payload, it will send OK. And so the leader will get OK from acceptor, so it will recognize itself as the active leader. It means that it will take care of propose in the next steps. So if the replica sends propose to the leader, it will for each command, the leader will generate a commander, and this command will send broadcast P2A message to all acceptors. And if it got the majority of acceptors, and it will make a decision. The decision is that in which slot the command will be executed, and it will send this decision to the replicas, and the replica will execute the decisions in the order of the slot. For each slot, it will execute 1 command. So for replica, all the replica can execute the decisions in the same order. So it will send a response to the client. So here's in my rows in my Paxos, and we can see this is high level what it is doing, and this is a detailed algorithm. So we can see if it got, for example, if it got a propose or it got the SCANT from adopted from SCANT or something, it will have specific reactions, and the commander SCANT is a function within it, and the acceptor here, this is what it is doing, and the replica, here's high level what it is doing, and the detailed algorithm, and this is an abstract thing. So for my implementation, here's a more detailed. It's not including all of the things, but it includes a lot, like timers, messages, what kind of things I have defined, what kind of functions I have defined, and what did the function do here, for example here. And timer handlers, it means that when the timer is on, the handler will deal with that timer, for example the heartbeat check timer. And I'd like to introduce how I implement the stable leaders. It is implemented through heartbeat. We can see here the stable leader. So there are a lot of leaders in this system, but it's actually only one stable leader. This stable leader will make decisions, and other leaders will just follow what this stable leader do. So this stable, if a leader is a stable leader, I can see it is active, and if it is not a stable leader, it is inactive leader. So what is going on here is that every Paxos server has a heartbeat checker timer, and this timer will check if it receives a heartbeat from active leader, and if a leader is active, it will send heartbeat to anyone else, and it will send this heartbeat periodically, and each server will check if it has received this heartbeat. If it received, it means that there's an active leader here, so it will not try to become the active leader. And if the active leader, if it is not receiving the heartbeat from active leader, it means that this active leader may crash, so it can start to elect for the active leader. Election means here it will generate a scan to send P1A for acceptor to get OK from acceptor. If they get the majority of the acceptors OK, it will become leader. So this is how we can stay as a stable leader. And so for the garbage collection, so how can we collection garbage is right? We can see here. So for each server, we have a lot of slots, and for each slots, we will give it a command. For example, A, B, to C, and D, and E. So for each slot, we have a command to assign to it. So and there's two variables. One is slot out, and the other one is slot in. So slot out means that the slot out means that the last slot we have executed, and the slot in means that the next slot we will assign a command. So for different servers, we have different slot out because they have different execution time, right? So every server will have different execution. So how can we delete the logs that has been executed? So here's what. So this is why we need the garbage collection. So we can see here how can I implement it here. So each follower server responds to a heartbeat with a message containing the latest slot they have executed. So it will, so in the heartbeat of the leader, the active leader will send heartbeat to anyone, and the others will reply this heartbeat with its own slot out. It means that which one I have executed. So if the active leader get this message, it will figure out which commands, before which commands, all the commands has executed by all the servers. So it will include this message into next heartbeat. So everyone will get the next heartbeat. If they get this heartbeat, they will get the information, and then they can delete that message in the logs, that commands which has been executed by anyone. So this is garbage collection. And for state reduction, it just means that acceptor only maintain the most recent accepted p-value for each slot. If we don't have state reduction, that the acceptors will store a lot of unused things. It's not very necessary. So it's optimization. We can just maintain the most recently accepted values for each slot. So we can store less things, and we can send less things because these values will be in every message. So in this scenario, we have optimization. And other optimizations is like for active leader, because every leader will broadcast like P1A and P2A to every other servers. So if one server gets others P1A and P2A, it will know that if it is a leader or not, if it should stick to the leader or not, because every message has a beta num. Whose beta num is higher, it will be the leader. So this is how I implement this part. And the last thing is that I didn't deploy the Paxos in real world. This is because I implement in this framework. If I want to put it in the real world, it's tons of time, and I don't think there's more implications because these tests they have very realistic environments, and they can test on reliable network. And in real scenario, I will use TCP, and this is actually reliable. So I don't think we need to do that. And if we do that, that consume a lot of time, and it will not give me some improvements or something. So I don't think that's feasible. So this is all.